Okay, so solving the equations by clearing the denominators. What does that mean to clear the denominator or clear the fraction? That means to multiply, so let me get this over here, to multiply by the denominator. If you are multiplying by the denominator, it is going to eliminate the fraction. And that's always our goal. I know how much you guys really hate fractions, so eliminate the fraction. So let's try that concept with these examples. So again, what's the denominator in this fraction? It's a 3, so I'm going to multiply by 3. And if you do that to one side of the equation, you have to do it to the other. And so if we do it out the long way, just to prove a point, we would do 3 times 4d, and we would get 12d, and in the denominator we'd get 1 times 3, or 3. And I know what you're saying right now. That's still a fraction. We didn't get rid of the fraction, but actually we did, because 12 divided by 3 simplifies to 4d equals 36. Divide both sides by 4, d equals 9. And so some of you might have, right from the very beginning, knowing that if you were dividing by 3 and you multiplied by 3, 3 divided by 3 cancels, leaving you with 4d, which is essentially what we got after we simplified. So you can kind of skip this step if you understand why it happens, then you don't need to do this step. So let's look at this example. We are going to first multiply by the denominator. We're not going to isolate the variable first. We're going to multiply by the denominator, and the denominator is 4. That means that every term is going to get multiplied by 4. Okay, every single term gets multiplied by 4. So 4 times 2x is 8x. These 4's will cancel because that's a fraction, and I'm going to be left with plus 3, and then 4 times 1 is 4. Now I'm left with an equation that has no fractions in it, and I can just very easily solve. I don't have to stress out because there's a fraction in it or skip it. Undo positive 3 with negative 3, both sides of the equation. There's my 0 pair. 8x equals 4 subtract 3 is 1. Divide both sides by 8. X equals 1/8. Okay, look at this example. Oh my gosh, Miss Peltier, there's a variable in the denominator. I'm supposed to be multiplying by the denominator. It doesn't matter if it's a number in the denominator. It doesn't matter if it's a variable in the denominator. Whatever is in the denominator is what you multiply by. So I'm going to multiply by x on this side of the equation and by x on this side of the equation. They're going to cancel. 10 equals 2x. And then I'm going to, again, remember my balance. If this is being multiplied by 2, I'm going to divide by 2. 10 divided by 2 is 5. Okay, this box is for you to pause the video if you want to for a minute and just kind of make some notes to yourself about some of the things that we just did right here so that when you look at them later, you remember how we did them. Okay, moving on. Extraneous solutions. Most of the time you heard about extraneous solutions in Algebra 2. Okay, an extraneous solution is an answer that you get that appears to be appropriate. But, always the but, right? But, unfortunately, when you test it, it doesn't work. Okay? So, example. Look at this example. We're going to multiply both sides by the denominator. So here's your x. Let's multiply both sides by x. Cancels on the left. 0 equals 5x. and then divide both sides by 5. 0 divided by 5 is 0, so we get x equals 0. So here's the deal. Plug it back in, see if it works to the original equation. 0 divided by 0 equals 5. Is that true? 0 equals 5? No. So this is an extraneous solution. It appears to be proper, and it's just not. Second example. Again, we are going to multiply by what we see in the denominator. Even though it's a binomial, no big deal, right? We can still do this. These cancel. 12 equals, we're going to do the distributive property. 1 times q is q. 1 times 6 is 6. We're going to then subtract 6 because we remember this is where our balance is. That's our 0 pair. Q equals 6. Let's check. 12 divided by 6 plus 6 equals 1. 6 plus 6, it is 12. And 12 divided by 12 is 1, and 1 equals 1. So the moral of the story is that you look at these answers, they seem legit. This one seemed like a very legit answer, but it did not work. And this one actually does work. So it's always important to test just to make sure you don't have an extraneous solution. Okay? How do you clear all the fractions when there is more than one fraction? How are we going to do that? So the first thing we're going to do is find the common denominator. Okay, and then we're going to multiply by it. So more than one fraction. Find the common denominator, then multiply by it. These two titles should be on top of the second page. So this is just going to say, show each step to solve for r, and then this is where we're going to explain the steps. So let's go ahead and look at the second page. And we're going to use that strategy of finding the common denominator and then multiplying by it. So this is going to be a little bit of a challenge in this particular problem because there's lots of denominators here. So we need to find the common denominator. And so all the denominators are r, 4, 10, and 20. So I need to first know the largest number that goes into all of these, the largest number that all of these go into evenly. Okay, so does 4 go into 20 evenly? Yes. Does 10 go into 20 evenly? Yes. And does 20 go into 20 evenly? Yes. And then we have to tack on this r because it is a denominator and we do need to have it in our greatest common factor. So the common denominator is going to be 20r. And so then we need to multiply every single term by that 20r. So I'm going to write this out the long way. 20r times 1 over r equals 20r times 1/4 plus 20r times 1/10 plus 20r times 1/20. And then we're going to simplify. Okay, so now it's time to simplify. So looking over here, 20r times 1, multiply this together. What do we get? We get 20r divided by r equals, again, multiply across the top. 20r times 1 is 20r divided by 4 plus 20r times 1, 20r over 10 plus 20r times 1 is 20r over 20. Let's simplify again. r divided by r cancels. 20 equals 20 divided by 4 is 5r plus 20 divided by 10, 2r plus 20 divided by 20 cancels. Go ahead and add those together. 5r plus 2r is 7 plus 1 more is 8r, and then divide both sides by 8. 20 divided by 8 does not come out evenly, but it certainly does reduce. Both of those divisible by 4. 20 divisible by 4 is 5, and 8 by 2. So we get 5 over 2, or 2.5 as our answer. So find the common denominator, the number that all of these go into evenly. If there's a letter, tack it on. Multiply every term by that common denominator and simplify. Okay, a little bit of a rough bunch of steps to get through. We're going to certainly do lots of practice with this. Let's talk about applying this concept to problems involving time, work, and rate. So let's clear the screen and scroll up a little bit. Okay, so, oops, sorry about that. Move the whole screen. The amount of work, right? So we're talking about the amount of work here. Formula for a job when machine A and machine B are working together. So first of all, the formula for the amount of work is just the rate of work times the time that is that you're working. So rate times time, and that's work. That's the basic formula for work. Work equals rate times time. Sometimes, though, we have two machines working together at the same time to accomplish a larger job. And so how do we do that? So we do the work of A plus the work of B is going to equal the total job done. Okay? And so it's going to involve addition. You add them together when they are working together. We add, okay? When they are working in opposition, so they're working against each other, you find the work of A and you subtract the work of B. Since they're not working together, they're working against each other, we have to take the difference. So we have to subtract, okay? Now let's put this into practice, one of each kind of problem. This one goes along with the first one. It's just a simple work problem. A carpenter can install one door for every 3 hours. That's the rate at which he can work. We are trying to find the number of doors that he can install in 40 hours. So the 40 hours is the time. Okay, so number of doors, we'll call that X, equals the rate, one door per every 3 hours, rate times time. And the time is 40 hours. Now, you're going to notice, if you look at this, it kind of looks like two fractions if I put this over 1. And we want it to be that way. You want the two similar terms to be one in the numerator and one in the denominator, and that is so that you can simplify it when you're finished. Hours divides hours out. You're looking for the number of doors. Hours has nothing to do with that, so it better cancel, which it does, and that's great. Multiply across the top. 40 doors divided by 3. 40 divided by 3 is approximately 13 1/3. So it looks like 13 doors because you're not going to count a third of a door. He can complete 13 doors in 40 hours time. Rate times time. Okay. Looking at the next page, we have a couple of examples. The first being a pipe filling a tank in 6 minutes. So one tank in 6 minutes. Okay. And a second pipe is filling the tank in 8 minutes. Now they're both filling, so they're working together. That means we're going to add. Okay. And so this one's working at a rate of 1/8. I need to move that addition sign over a little bit. Hang on. So I have the job takes 1/6. One tank is filled every 6 minutes. The second machine or pipe is one tank fills every 8 minutes. And we're wondering how long does it take for both pipes to complete that one job. So remember, we have to find the common denominator. So what number does 6 and 8 go into evenly? That would be 48, and then we need to multiply every term by 48. Okay, so we're going to do 48 times 1/6 x plus 48 times 1/8 x equals 48 times 1. So every single term, even the one on the other side of the equation. So let me just change the color so this stands out a little bit to you. We're going to multiply across the top. I'm going over here now. We get 48x divided by 6 plus, multiply across the top here, 48x divided by 8 equals, and then multiply these guys, 48. Do some division or some simplifying. 48 divided by 6 is 8x, plus 48 divided by 8 is 6x equals 48. Add the 8x and the 6x together to get 14x equals 48, and then divide by 14. So x equals approximately 27 over 14, which is, because those are both divisible, right? So we get simplified to 24 over, I'm sorry, I should have fixed that. I got that all mixed up. 48 divided by 14. Let me fix. We have 48 divided by 2, which is 24, and then 14 divided by 2, which is 7, and that gives you about 3 3/7. So it takes about 3 3/7 minutes for both of those pipes to fill the tank if they're working together. Now let's talk about what happens when they're not working together. So a faucet fills a tank in 6 minutes. So fills the tank in 6 minutes. The drain, so we're not filling, now we're emptying, empties the tank in 8. So now we're subtracting. How long will it take for both of them? If the faucet and the drain are open, how long will it take for it to overflow if the faucet's not turned off? So how long before this becomes a huge problem? Again, common denominator is 48. We're going to do this exactly the same way we just did the last one. 48 times 1/6 x minus 48 times 1/8 x equals 48 times 1. Do some simplifying. If you want to skip this step where we multiplied across the top and wrote the fraction down and then simplified it out, you can. But if you really are unsure or afraid that you might forget a step or make a mistake, you definitely want to write it down. So again, across the top, 48x over 6 minus 48x over 8 equals 48. 48 divided by 6 is 8x minus 48 divided by 8, which is 6x, equals 48. 8 divided by, or 8 minus 6 is 2x equals 48, and divide by 2. So we get x equals 24. It's going to take 24 minutes if the drain and the faucet are both open for it to really start overflowing, because obviously it's filling at a little bit of a slower rate than it is emptying. It's filling faster than it's emptying, so eventually it's going to overtake it. Okay, so that is clearing your fractions, multiply by the common denominator when there's more than one fraction. All right, clearing decimals is a little easier, takes a little less time, and then we'll be finished. How do you clear a decimal? So the first thing you do is you move the decimals to the right until all of them are whole numbers. So however many spaces that takes, okay, and they have to all move the same number of spaces. Just be careful about that. All move the same number of spaces. So what do I mean by that? So you look at this one. 2 spaces until it's a whole number. This one's 1 space until it's a whole number, and this one's 1 space till it's a whole number. So I have to move every single decimal point 2 places to the right because I need every single number to be a whole number. So 2 places to the right means that I'm going to have that one going 2 places to the right. Right, I'm going to have this one going 2 places to the right. And I'm going to have this one going 2 places to the right. They all have to go 2 places in this particular problem. So I get 38 plus 110y equals 60. And then I have an equation that I can solve so easily without having to worry at all about decimals. So I have 110y equals 22 divided by 110. Y equals 11 over 55, or about 1/5. Okay, I left this box here for you to do some talking to yourself, writing some notes to self about that. And then the last thing you're going to see are interest, principal, and time problems. I equals PRT. You're going to see this a lot. The thing that you need to remember about this is that when you plug in your percentages, they have to be plugged in into their decimal equivalents. Okay, so you need to move this decimal 2 places to the left to turn it into a decimal. So 1, 2 to the left. So 6.25% is 0.0625. That's the number that you need to input into the formula to do the work. Same thing here, 4.5%. So 2 to the left makes it 0.045. Okay, so very, very important. Left 2 places.